In this video, you will learn about the conic section, the parabola. So let's talk about what we already know about parabolas. Since y equals x squared was one of our parent functions, we knew that if we graphed it, it would have a vertex at 0, 0 and would go through the point 1, 1. And so we could sketch this graph looking like this. We also knew that if we put a minus sign in front of that, it would reflect it on the x-axis, and I would get something that looks like this. So that's helpful for us to know. So when we learned about the toolbox function of just y equals x squared, we really didn't talk about what makes a parabola a parabola. And it turns out that what makes a parabola is that every point on the parabola, whatever point that is, it's equally distant to the focus and also to this imaginary line called the directrix. So if I choose a different point on the parabola, it'll be further from the focus, but it'll also be the same distance from the directrix. So that's what makes a parabola a parabola. A couple of other things that we know about parabolas. The axis of symmetry goes directly through the focus. And what we just saw was that if our x squared term was positive, it opened up, and negative, it opened down. We also have this distance. The distance between the focus and the vertex, which is a point on the parabola, is got to be the same as this distance here. And we call that distance p. And that comes into play when we use the conic form of a parabola. So let's take a look at that conic form. The conic form of a parabola opening up or down with the vertex at the origin is x squared equals 4py. In this particular case, p is the distance from the vertex to the directrix, which we just marked on the picture above, and the distance also from the vertex to the focus by definition. If the p value is positive, it's going to open up. Negative, it's going to open down. The directrix, that imaginary line behind the parabola, is y equals minus p, and the focus is 0p. We can also have a parabola that opens to the right or to the left. Now keep in mind this is not going to be a function because it won't pass the vertical line test, but it still is the same formula or the same definition where the focus and the directrix are equal distant from any point on the parabola. So if that's the case, if it opens left or right, we're going to have y squared equals 4px. P is that distance we talked about. If P is positive, it'll open to the right. Negative, it'll open to the left. The directrix is x equals negative P, and the focus P0. So my table got split on two different sides, but I have fixed this on the next slide. Let's take a look at all of the different kinds of parabolas that we could get. If we have a vertical axis of symmetry, up and down, then if P is positive, it's going to open up. If P is negative, it's going to open down. So these would be of the form x squared equals 4py. Down here, if we have a horizontal axis of symmetry, these will be of the form y squared equals 4px, and if p is positive, it will open to the right, and if p is negative, it will open to the left. Now, for each of these, if we have our point, in this case 0p, our directrix will be an equal amount behind it, and since it crosses the y-axis, it will be y equals negative p. Similarly, for this one, y equals negative p, and this is 0p, but keep in mind our p value in this case is negative already. And then down here, our focus will be on the inside, our directrix will be an equal distance behind it. And since our directrix crosses the x-axis, if this is 0p, this will be x equals negative p. And similarly here. So let's take a look at some examples, because I know this, what you're used to seeing is a standard parabola, y equals x squared. So what we want to do is we want to write it in standard form, which is either x squared equals 4py or y squared equals 4px. We want to find the vertex, the axis of symmetry, the focus, the directrix, and sketch the graph. So what I like to do is just find my p-value first. So this is, I want to put this in the form x squared equals 4py. So if I multiply both sides of this equation by negative 12, I will get x squared equals negative 12y. So I know that this is of the form x squared equals 4py. So that means that this negative 12 is 4p. So if 4p equals negative 12, p is negative 3. All right, what does that tell me? Well, I started with an x squared, so I know it opens up or down, but in this case, it's going to open down. We also know that our vertex is 0, 0. And, excuse me, and it will have a, if it's opening down, it will have a focus here and a directrix 3 units behind it. Now it's nice to have maybe just one more ordered pair. So let's let x equal 1, just so we know how wide this is. So if we let x equal 1, and I'm going to plug it into the original, I get y equals negative 1/12. So I plugged that in right here. And so 1, negative 1/12. So this is pretty darn wide parabola, but you can see what's going on here. Now what's the vertex? The vertex is 0, 0. Our axis of symmetry goes straight through the focus and the vertex, so that is going to be the y-axis, or x equals 0. The focus was 0, negative 3, and our directrix crosses the y-axis at 3, so it's y equals 3. So let's take a look at a couple of other examples. This one is y squared equals 6x. So clearly this is of the form y squared equals 4px. And so 4p, you can see, plays the part of that 6. So p in this case is 3/2. And it's positive. So if I have a y squared, it's going to open right or left. Our standard form, our vertex is 0, 0. It's already in our standard form. So here's our 0, 0. I know that our focus, it's going to open to the right. So I'm just going to kind of sketch it because I don't really know how wide it is just yet. And 3/2 in front of it is going to be my focus, and 3/2 behind it, which is 1.5, is going to be my directrix. So we can say that our focus is 3/2, comma 0. Oops, I wrote that on the wrong spot. 3/2, comma 0. And our directrix is that imaginary line behind it, which crosses the x-axis at -3/2. Our axis of symmetry in this case goes through the vertex and the focus. That is the x-axis, or y equals 0. And then before I sketch it, again, I'd kind of like to know how wide it is. So I'm going to let x equal 1. It seems pretty straightforward. So y squared equals 6. So y is plus or minus √6, which happens to be approximately 2.4. On our graph here, I can go 1, 2.4, and 1, -2.4. So my original sketch wasn't terrible. And it will look like this. Just like we were able to shift our circles and ellipses and hyperbolas, we can shift the vertex of the parabola. So it's exactly the same form. It's really just x squared equals 4py, only we are shifting the x h units and the y k units. So our vertex in this case is going to be hk. Remember that it's kind of opposite of what you think. You might think it should be a negative, but the negative is part of the formula. P is still the distance from the vertex to the directrix and the vertex to the focus. P positive is still opening up, P negative opening down, and so on. So I don't worry too much about these here. I use my graph to tell me what my focus and my directrix are. You also, just as the others, if we have to, we might have to complete the square to put this parabola in standard form. So this first example is already in standard form. And I can tell right away that my vertex, let's move it up here, my vertex is -2, +1. So I'm going to mark that. -2, +1 is my vertex. I also can tell that my 4p is 16, so p is +4. So again, is that distance that we're looking for. So this starts with an x squared, and my p is positive, so I know that it's going to open up. So again, I don't really know how wide just yet. I'm going to find an ordered pair, but I'm just going to kind of sketch it going up, because then I know that 4 units in front is my focus, and 4 units behind, not a point but a line, is my directrix. And my axis of symmetry is going to go straight through my focus and directrix here. So my axis of symmetry crosses the x-axis at -2. My focus appears to be -2, 5. And my directrix crosses the y-axis at -3. Now, before I sketch it, I'd like to know how wide it is. So the nice thing to know in this case would be our y-intercept. So let's let x equal 0. If I let x equal 0, I get 2 squared equals 16 times y minus 1. 4 equals 16y minus 16. 20, if I add 16, equals 16y. And then dividing by 16, these are both divisible by 4. I get y equals 5/4. So a little bit more than 1. So this is actually wider than I initially thought. And we know it's symmetric. So let's see if we can get rid of these dashed lines here. Okay, and then I will sketch our graph, which looks like this. Okay. Let's take a look at another example. In this case, this is not currently in standard form, so we need to complete the square. Now I know I have an x squared, So I want this in the form x squared equals 4py. So I want x's on this side and y's on this side. So we're going to start with x squared plus 6x equals minus 4y minus 5. Now I want to complete the square for the x's, and if I do that, half of 6 is 3, and 3 squared is 9. So we will add 9 to both sides, and then we will factor. So this will be x plus 3 squared equals minus 4y plus 4, and we're close. We have the x squared piece, but we want this to be something times a y piece. So we're going to, in this case, I noticed that they're both divisible by 4. Regardless, I would factor out the coefficient of the y, and this would give me y minus 1. So this is our standard form, and we can see from this that our vertex is negative 3, 1 here. Our 4p is negative 4, so our p is negative 1. And it starts with an x squared, which is either up or down, and our p-value is negative, so I know it's going to open down. I just don't know really how wide it is. So our focus is 1 unit in front here, and our directrix is 1 unit behind here. And so let's see what our focus is. It's going to be negative 3, 0, and our directrix is crossing the y-axis at 2. And our axis of symmetry goes right through our focus and our vertex at x equals negative 3. Remember, it's always the axis, or the axis that it crosses. And then, like before, let's see if we can't actually find about how wide it is. Let's let x equals 0. That will be our y-intercept. And if I let x equal 0, I'm going to plug it into the original here because it seems to be easier. So I'll get 0 plus 0 plus 4y plus 5 equals 0. And I get y is minus 5/4, so a little bit more than negative 1. So here and here, because it's symmetric, and it looks like this. Okay, these last two examples are actually given particular information about our parabola. We would like to be able to find the equation of the parabola. So first of all, we know that our vertex in this case is 0, 0. And our focus, so this is our vertex, and our focus is negative 3, 0. So what that means to me is that this is going to open to the left, because we know that our focus is always kind of inside the parabolic shape. And because it opens to the left, it's going to be a y squared. We know that the vertex is 0, 0, so this is the form. And this distance here is 3, and we know that that distance there is our p-value. So we know that p is 3. So we get y squared equals 12x. Let's see if we can do that again with some different information. Let's say we have a focus of 0, 5 here, and our directrix y equals negative 5 back here. Well, since our vertex has to be the same distance from those two, we can see that our vertex here is 0, 0. And that this is going to open up because our focus should be on the inside of our parabolic shape. That means it's going to be an x squared equals 4py. And we just need to know that p-value, which is 5 in this case. So our final answer here is going to be x squared equals 20y. So I'm just plugging that 5 in there. That concludes this video on parabolas. I hope you have learned something and can apply what you have learned.